This is an example of an integration by partial fractions. This particular example is somewhat difficult, long and complicated. I hope that you will not get an example like this in exam, maybe as a take-home assignment or so, right? But not in a sit-down exam. Now, here you have x cubed plus 2x squared minus x minus 2. We want to find what the factors are for this. So let's put this aside. X cubed plus 2x squared minus x minus 2. Let's look at this. Suppose we consider the x cubed and the x squared here and factorize just these two alone. We have x, then x squared plus 2x. Oh, we could take out x squared. Right. X squared is the highest common factor. So inside the bracket we have x plus 2 minus x minus 2. Alright. We have an x plus 2 in brackets. Suppose we put a bracket around this, we would have an x plus 2 in another bracket. So this is equal to x squared, x plus 2 minus open bracket x plus 2. See that? Alright. Now what is that equal to? Or we could factor out the x plus 2, as a common factor. X plus 2, because this x plus 2 here is a common factor here. So what you have inside the bracket is x squared. Okay. X plus 2 times this gives you x squared x plus 2. So this is x squared. You have a minus sign. Minus. Alright, let's close the bracket and figure out what we're going to put here. X squared times this will give us, no, x plus 2 times this will give us x plus 2. It's going to be 1. Alright. Now it could be factorized further, because notice that we have an x squared minus 1, which is a difference of 2 squares. So let's put back the x plus 2 here, and then here. The shortcut for factorizing this difference of 2 squares, we're going to have x plus 1, x minus 1. Remember your difference of 2 squares? Alright, so that's what we have here. Alright, so we can write this thing as integral of 5x plus 7 over. So we have the integral of 5x plus 7 over x plus 2, x plus 1, x minus 1 dx. Now let's deal with the partial fractions part. So 5x plus 7 over x plus 2, x plus 1, x minus 1 is equal to, these are distinct linear factors. That means they are linear, right? The highest power of x is 1, so it's x to the 1 in each. And they are distinct, they are different. So what you're going to have here is the form a over x plus 2 plus b over x plus 1 plus c over x minus 1. That's the form the partial fractions will take. So what we have here now, what we're going to do is multiply by x plus 2, x plus 1, x minus 1. See that? That's what we're going to do. When we multiply everything by x plus 2, x plus 1, x minus 1, all of this will cancel. See that? Because what we have is going to be 5x plus 7 over x plus 2, x plus 1, x minus 1 equals, we have a over x plus 2, I'm putting some space between them, plus b over x plus 1 plus c over x minus 1. So what's going to happen here? You multiply by x plus 2, x plus 1, x minus 1. What happened? X plus 2 cancel x plus 2, x plus 1 cancel x plus 1, x minus 1 cancel x minus 1. So you only will have 5x plus 7 here. Then you say equal. Then you multiply this by x plus 2, x plus 1, x minus 1. X plus 2 will cancel x plus 2. See that? So all you're left with here is a x plus 1, x minus 1. See? Plus, and then what's going to happen after that? My, this thing keeps jumping up and down. You're going to multiply this by x plus 2, x plus 1, x minus 1, x plus 1 will cancel x plus 1. So here you're left with b times x plus 2, x minus 1. See that? Plus, what's going to happen out here now? You have x plus 2, x plus 1, x minus 1. Multiply. X minus 1 will cancel x minus 1. So what you have left is c times x plus 2, x plus 1. Right? So you have all of that. Now, the next thing is going to multiply out the brackets. So we have 5x plus 7 is equal to a times, when you multiply out the brackets, you have x squared minus x plus x, that will disappear, minus 1, right, plus b times, you have x squared minus x plus 2x, right, see, x squared minus x plus 2x, but what's going to happen here? Negative x plus 2x, that's with 1x. So you can say plus x, 2 times negative 1 minus 2. Alright? So we have that. Plus, and this is going to be c times x squared plus 1x plus 2x, that's going to be plus 3x. 2 ones 2 plus 2. So there we have that so far, right? So here, let's expand the bracket and isolate the x squared, the x, and the numbers. So what you have here is 5x plus 7 equals, you have a x, let me write it like this, a x squared minus a plus b x squared plus bx. Going to write the x squared in red, the x is in blue. Then you say minus 2b. So these are the numbers. You have 2b. Write the numbers in yellow. Alright. And of course here, this is 1a, so let me write 1a as well. Right? 1a. Then what happens after this? Plus. Then you have c x squared. So you have c x squared plus 3cx, right, plus 2c. All right. So here now we have ax squared minus 1a plus b x squared plus bx minus 2b, all right, plus c x squared plus 3cx plus 2c. All right. So here now, let's put like terms together. Now you have a 5x. So we have 5x plus, you have a 7 there. Let's put the numbers in yellow. Equal. Now the x squared parts. You have a x squared plus b x squared plus c x squared. All right. We just want to separate them, not only by the x squared but by colors as well. We can see what's going on. Then after this we have plus x's now. I want x's in blue. We have bx plus 3cx. Why this thing jump all the way up there? No other x? Alright, no problem. Then the numbers now. Then we have minus 1a minus 2b plus 2c. Hopefully we accounted for everything. So what we have here is 5x plus 7 equals, let's put x square outside the bracket, x squared times a plus b plus c. And as I told you before, I knew that this was a lot of work, right? Hopefully they don't give this to you in an exam. Well, maybe you'll get it, but you'll have enough time to work it out and you're compensated with a lot of marks, right? Plus we have x and then b plus 3c. Then we have here plus, then we have here, call it negative a minus 2b plus 2c. Alright, so that's what we have at this point. Alright, so let's equate what we have on the left and on the right. We see here that x squared can be written on the left as 0x squared. So, comparing x squared and x squared, we can say that a plus b plus c is equal to 0. See that? 0, this left and right are equal. So 0 times x squared is equal to a plus b plus c times x squared. A plus b must be 0. Then here, 5 times x is the same as b plus 3c times x. So that means b plus 3c must be equal to 5. And then 7 is equal to, let's put the positive one first, 2c minus a minus b. So we have 2c minus a minus b is equal to 7. Well, we have 3 simultaneous equations to solve. Now, let's see what we can do with this. Suppose we have this as equation 1, equation 2, equation 3. We can use what they call Gaussian elimination method to work this out. Suppose we multiply, say, equation 1 multiplied by 3. So we will have 3b, it's writing right, 3b plus, this would be, this equation 1 I'm multiplying equation 1 by 3. We would have 3a plus 3b plus 3c equals 0. And then we put back equation 2, b plus 3c equals 0. And then, remember this is equation 2, and then we subtract. 3a minus 0 is 3a plus 3b minus b is 2b equals 0. See that? So we eliminated c. Now, let's consider equation, equation 3. Suppose we multiply equation 3 by what now? By 2. Equation 3 multiplied by 2. So, or let's try another strategy. Equation 1 times 2. Suppose we multiply equation 1 times 2. We'll get a 2c. And then we could eliminate the c. Right? So, we have equation 1 times 2. Equation 1 times 2. We have 2a plus 2b plus 2c equals 0. Let's write back equation 3. Let's put them in order. Negative a minus b plus 2c equals 7. See that? This is equation 3, And then, suppose we subtract. 2a minus negative a is 3a. Then 2b minus negative b is 3b. 2c minus 2c, that's 0. And then 0 minus 7 is negative 7. So what we have here are two equations in two unknowns. So we could solve for a and b. So here, let's put them together. 3a plus 3b equal negative 7. 3a plus 2b equals 0. If we subtract these, 3a minus 3a, that's gone. 3b minus 2b is b, equal 7 minus 0. Negative 7 minus 0 is negative 7. So we see that b is negative 7. Right? Alright, b is negative 7. So let's write that up here. B is equal to negative 7. Right? I'm not able to scroll down any further. I've run out of space. But let's continue working. B is negative 7. Now here, 3a plus 2b is 0. So let's work with that. So 3a plus 2b equals 0. So 3a plus 2b equals 0. That means 3a plus 2 times negative 7 equals 0. So 3a minus 14 equals 0. Right? So that means 3a is equal to 14. So a would be 14 over 3. Alright? So a is 14 over 3. So we know that b is negative 7. B is equal to negative 7. And then let's use equation 1. A plus b plus c equals 0 and see what it comes out to be. A, which is 14 over 3, plus b, which is negative 7, plus c is equal to 0. So now it is the same as 14 over 3 minus 7 over 1, which is the same as 7 3 is 21. So it's 21 over 3 using common denominators. This is 21 over 3 plus c equal 0. So 14 minus 21 is going to be what? Negative 7 over 3. Negative 7 over 3 equal negative c. So c is equal to negative 7 over 3. C equal negative 7 over 3. Alright? So that's what we have working with. A is 14 over 3. So let's scroll back up here. So this can be written as the integral of 14 over 3 over, and it was a over x plus 2, so it's x plus 2. Alright, what was b again? B, negative 7. So we have negative 7 over x plus 1. So we have minus 7 over x plus 1. And then we look back at c. C is negative 7 over 3. So it is negative 7 over 3 over x minus 1. Alright. This is the same as, now if we integrate them individually, we have the integral of 14, well, we could put the 14 over 3 outside the integral sign. Alright, 14 over 3 integral of 1 over x plus 2 dx. Oh, I didn't write the dx here. Dx, then minus 7 integral of 1 over x plus 1 dx, and we say, what was it again, minus 7 over 3 integral of 1 over x minus 1 dx. So what we have then is this. When you integrate, you could use substitution to do this, right? But you're going to end up with the same thing. 14 over 3 ln x plus 2, right, minus 7 ln x plus 1 is going to be ln x plus 2 times the derivative of x plus 2, but the derivative of x plus 2 is 1. Alright, so it's same as saying putting it over 1. The derivative of x plus 1 is 1. If you remember your substitution, alright, minus 7 over 3, same thing happens here, ln x minus 1 plus c. So that's what you would get there. So quite a bit of working, going through the algebra and so on and so forth. But as I say, I told you that it will be a lot of working here. You even use the Gaussian elimination method, where we use elimination to solve 3 simultaneous equations in 3 unknowns. So hopefully, if you get this as an assignment, if you get this, it would be as an assignment. You're not unfortunate enough to get this in a sit-down exam, right? But anyway, I'll see you in the next video.